Okay, here we go. Friday's lesson. Go ahead and get out your homework. Let's see. So when I say the square root of something, it's math formatting. When we say instead of square root of 7, we'll say like root 7. So that's what that will mean when I call out the answers here. Here we go. 2 through 26 evens. Number 2 is 2 root 7. So that means 2 times the square root of 7. So 2 root 7. Got it? All right. Number 4 is 5 root 2. Number 6 is 2 root 6. Number 8 is 2 root 30. Number 10 is 36 root 3. Number 12 is 9 root 90. 9 square root of 90. 14 is 18. 16 is 70 root 3. 18 is 12 root 6. 20 is 12 root 10. 22 is 12 root 3. 24 is 44 root 3. And 26 is 45 root 7. Okay, all my geometry students are so used to doing these that I can't stress enough how important this lesson is for next year in geometry. You're going to take square root many times, and you have to be able to simplify it. Okay, hey, if there's truly any questions on this, make sure you ask. All right, I didn't make it white, but today is 11.5. Today's another pretty important lesson. We're going to power through this one today, and we got one more week of actual lessons, and then we'll start reviewing for the semester final. All right, today the homework is worksheet. It's on the bottom of the Google Forms. Also, because we're doing a lot with square root symbols and squares and exponents, I'm not going to have you fill in any questions, like I normally ask you to fill in a box, whatever. But I do want you to fill in question number 1 for the Google Forms. Okay, so once again, this kind of pairs with the last 2 lessons, kind of finishes our study of taking square roots. And is really critical, really critical. So this one you might want to put some extra emphasis on the understanding. If there's any misunderstanding or I don't understand what you're saying here, make sure you send me an email. Let me help you out. Okay, 2 objectives here. I'm going to say that today is both easy and confusing. If you understand the rule, it's really easy. I mean, it's really easy. However, to get there, it can be confusing. All right, so today once again we're dealing with square root symbols, right? We all know that the square root of 9 is, that's right, the square root of 9 is 3. So the question is, what's the square root of w to the 6th power? That is what we will be dealing with today. We already know how to take the square root of integers. Today we'll learn how to take the square root of variables, and specifically variables to a power. Recall, why is the square root of 9 3? Well, it's because that 9 can be written as 3 to the 2nd power. And what I put there in red there are inverse operations of each other. You know, the inverse of addition is subtraction. The inverse of squaring is square rooting. And so what happens when you do 2 inverse operations, they cancel each other out. So if I got rid of what's there in red, I would just be left with 3. And that is why the square root of 9 is 3. Why? Because squaring and square rooting are inverse operations. They cancel each other out. Okay, so that's a quick explanation. Now this one's going to come out of the blue here, but just stay with me. Recall, we've dealt with exponents today. Remember, we're taking square roots of variables with exponents today. And we've dealt with exponents. We have a couple rules. I mean, we learned 3 rules this year. The rule of multiplication, the rule of power to a power, and the rule of division. So let's recall the multiplication rule. If you remember, when you have 2 variables that are the same base, right? X is the same as x. And when you multiply them, the rule is that you add their exponents. So x to the 5th times x to the 5th is x to the 10th. Okay. We also have power to a power. This is in red because this is the first one we're going to use. Power to a power rule is you don't add the exponents. The answer isn't x to the 6th. It's you multiply the exponents. Okay, so x to the 8th. So that means that if I have x to the 10th, well, I could rewrite that as x to the 5th to the 2nd power. You're like, okay, why would you do that? Just stay with me for a second. I could write x to the 12th as x to the 6th to the second power. I could rewrite x to the 8th as x to the 4th to the second power. Notice I took all of those variables to a power, x to the 10th, x to the 12th, x to the 8th, and I rewrote them as a power to a power. And further, I rewrote them as a power of 2, and that's what's critical. All right, so remember what we're doing, how does this help us, is that we're trying to take the square root of w to the 6th power, right? I don't know what the answer is. And I do know that the square root of 9 can be written as the square root of 3 to the second power. And what's in red there cancels each other's out, so we get to 3. Well, what we're going to do with that variable is we're going to rewrite it as something squared. We just did all this work here to show that I can write any exponent as something squared, right? So why is this important? Well, it's important because I can write w to the 6th power as w to the 3rd power squared. Do you see what I did there? I wrote w to the 6th power as w to the 3rd power squared. Well, w to the 3rd power squared is w to the 6th. Why did I do that? Because now I have inverse operations. The square root and the square cancel each other out, and I'm just left with w to the 3rd power. Why? Because squaring and square root are inverse operations. So how about w to the 8th? Well, I can write w to the 8th as w to the 4th to the 2nd power. And since squaring and square root cancel each other out, the answer is w to the 4th power. You're like, well, okay, I kind of see that, but it looks a little it's not really complicated at all. Check this out. If x is even, if x is an even power, to take the square root of any variable to an even power, you just cut it in half, right? The answer will be a to whatever x was divided by 2. Well, that's a pretty simple rule, right? But remember, that's when x is even. Okay, we'll talk about odd here in a little bit. But if x is even, you see what I'm doing there? The square root of some variable to an even power, well, the answer is just whatever that variable is and take the exponent and divide it by 2. So please write that down. This is the first rule. Okay? So how does that work? Well, I got a variable to an even power, and I'm taking the square root of the whole darn thing. I just divide the power by 2. What's 22 divided by 2? 11. The answer is w to the 11th power. I left that middle step there to show you what the real math is. The real math is, well, 22 can be written as 11 w to the 11th squared, right? 11 times 2 is 22. And since squaring and square root cancel each other out, then you're just left with w to the 11th power. All right, what's the easy rule? You just, as long as the exponent is even, you just cut it in half, right? Is the exponent even? Sure, cut it in half. Well, what's half of 2? Well, half of 2 is 1, right? So the answer must be w to the 1st power. Or in other words, just plain w. Remember that one. That one you're going to see a lot. So the square root of any variable squared is just the variable, right? Technically, it would be w to the 1st power. But, we're lazy. We don't put that 1 in. Starting to make sense? Okay, is the power even? Sure is. Cut it in half. Done. Is the power even? Yeah, cut it in half. All right, now you're getting to see how easy this is, right? Okay, so how about you do these really quick? Exactly, it's that quick, right? So, what do you got, McKinley? Yep, that's right. Isabel, second one? Yep, right? Easy, easy, right? What's the obvious question? Right? The obvious question is, well, what happens when it's odd? So, turns out there's a little bit of magic here, and the magic is pretty slick. All right, well, here's the magic. So remember I said that we have 3 exponents rule. We have the rule of power of the power, we have rule of division, we also have the rule of multiplication. And the rule of multiplication says when the bases are the same, you simply add the exponents. 6 plus 1 is 7, right? So here's the magic, right? If the power is odd, we can write it in such a manner, right? Just subtract 1 from the power, right? 1 from 7 is 6. So I could write that as w to the 6th times w to the 1st. Now, why am I doing this? Because now I have an even power for one of the variables. W to the 1st is odd, but w to the 6th is even. And I know from the previous steps that we just did that if the power is even, notice w to the sixth is even now, right? Well, I can write that as w to the third to the second power, which is just plain old, just cut half of it, right? And pull it outside of the square root symbol. Do you see what I did there? I took an odd power, subtracted 1 from it. Why? Because I can write any odd power as an even plus 1, right? 6 plus 1 is 7. Okay, so all I did was subtract 1, wrote it as w to the sixth times w to the first. That would be w to the seventh. Why did I do that? Because I know how to take the square root of an even power. You just divide it by 2. What's w to the sixth? What's 6 divided by 2 is 3. Pull that outside, but then we're left with that just plain old square root of w all by itself. Okay, because I can't take the square root of an odd power, or at least I should say it more precisely. I can't simplify the square root of an odd power. I can only simplify the square root of an even power. So once again, how does this work? Hey, I got an odd power. Subtract 1. That can be written as x to the eighth times x to the first power. Okay, I can take the square root of an even power. The square root of x to the eighth, well, it could be written as x to the fourth to the second power, right? In other words, that's just x to the fourth times the square root of x. Kind of see the pattern here. All right, so this is our second rule. And the second rule is when x is an odd. Now, this is going to look weird, but trust me, it's not that bad. Okay, so when the power is odd, you rewrite the variable. See, I wrote a. Take the exponent, that's x, subtract 1 from it. That would make it even, and divide it by 2. And then tack on the square root of that variable. You're always going to have, for the odd ones, you're always going to have the square root of that variable. And technically, that's going to be to the first power. All right, I know a few of you are probably caught on this immediately. Some of you are like, what? So please write this down, right? And let's do some examples, okay? So let's look at some examples. Okay, so let's see how this works. Okay. Also, don't get confused with the variables a and the exponents x. They could be any variable and any exponent. Okay, check out here. The exponent is odd. 11 is an odd number. So what does the formula say to do? It says subtract 1 from 11. That gives you 10, right? It can be written this way. Now, what's the square root of y to the 10th? That's even now. You simply take half of it. So half of 10 is 5, right? So therefore, it's y to the 5th times y. Now, technically, it's y to the first power. I left that middle step in there just to show you, right, that you have two inverse operations of each other. You're taking the square root of something that's been squared. Most of us don't think about that middle step at all. But we do have to think of that first step, the square root of y to the 10th times y to the first. You do have to think of that step. Okay, let's do another one. Okay, so remember, 21 is odd. It can be written in this format, right? Hey, now we have an even one. Half of 20 is 10. So the answer is x to the 10th times the square root of x. Okay? That middle step in there, once again, is just simply to show you that you are taking the square root of something being squared, so they cancel each other out. But it doesn't cancel out the square root of x to the first. It only cancels out the square root of x to the 10th to the second power. Kind of talking kind of fast here. All right, maybe we need to see you. Square root of x. Because remember, x is to the first power. So what's the square root of x? The square root of x is x. Because remember, you can't write x to the first power as being squared, right? All right. Okay. Okay, let's try this one. All right, got two problems here. Let's see. The power is odd. So it says subtract 1. 7 minus 1 is 6. Half of 6 is 3, so I'm going to get w to the third power and tack on the square root of w. Notice every single time you do one of these odd ones, you're always going to be left with the square root of whatever the variable is as part of the answer. W to the 11th, it's odd. Subtract 1, 10. Half of 10. Half of 10 is 5, so you get w to the 5th times the square root of w. Make sense? Okay, so probably what we need to do now is let's do both rules. Both half of them will be, or some of them will be even, and some of them will be odd. So go ahead. Okay, so this is a mixture of both even and odd powers. Go ahead and take a separate sheet of paper, write down these answers real quick. All right. What do we got? Shayla, first one, upper left. What do you got? Correct. Mariah, next one down. Be careful. That one's an odd one. Okay. That's right. So let's see. Odd. 7 minus 1 is 6. Half of 6 is 3. And you tack on that square root of w. Okay. What do you got? McKinley, bottom left. What do you got? Yeah, that's right. That one's even. That's an easy one. Isabel, upper right. What do you got? Yep. Even. That one's easy. All right, the challenging ones are odd, so let's finish up with two odd ones. Two odd ones. Landon, what do you got? Middle one, middle right. Yeah, 17 minus 1 is 16. Half of 16 is 8. Tack on that square root of w. Who wants the last one? Last one. Who wants it? Sarah, you got it? Yep, that one's odd. 13 minus 1 is 12. Half of 12 is 6. So we get what? X to the 6 times the square root of x. Very good. Okay. Some of you may need to rewind and do these again just to find the pattern. I'll just say, for those of you that are on it right now, you're like, I don't need to do any more of these. I got this. This is pretty simple, and it is. But some of you might need to see a few more examples to get a hang of this. Now, we can certainly make this more challenging. How do we make this more challenging? Add more variables. So we'll add more variables. But don't panic. The rules don't change. So what I want you to think about this is handling it one piece at a time. So let's see. We'll just go left to right. So if we go left to right, the first thing we got is, well, x to the 10th power. Well, that's easy. The square root of x to the 10th power, even, that would be what? X to the 5th. Now handle the y to the 5th. Y to the 5th is odd. So let's see. We got subtract 1. 5 minus 1 is 4. Half of 4 is 2. So we got a y squared and then a y. See what I did there? Okay, I just handled it one piece at a time. One piece at a time. All right, let's do the next one. Let's see. How about this one? Okay, so we'll do x to the 9th first. So 9th is odd. So let's see. 9 minus 1 is 8. Half of 8 is 4. So I'm going to get x to the 4th and a square root of x left on the inside. Okay, how about the y? Well, the y is to the 8th power. That's even. Half of 8 is 4. So check what the answer is there. Okay, so basically all we're doing is just combining these things. Now, I mean, these are going to get kind of ugly as we go forward in your studies. Not this year, but Algebra 2, Pre-Calc, Calculus. I mean, you can get 3 variables in calculus when you start doing stuff like this. But, I mean, the rules don't change. I mean, I'm teaching you literally the rule that you'll be using in calculus. This doesn't ever change. All right, how about this one? Let's see. The 30 is even. Half of 30 is 15. 7 is odd. 7 minus 1 is 6. Half of 6 is 3. And then tack on that square root of y. You're like, why don't I tack on the square root of x? Because remember, x originally was even. The ones that are even, there's nothing left on the inside. It's only the ones that are odd that you're left with the square root of that variable on the inside. And by the way, once again, it will always be something to the first power on the inside. One more? Okay, so this is the somewhat tricky one. Notice that it's x to the first power. If anything is to the first power, you do nothing with it. It's fully simplified, fully simplified. So I'm going to be left with the square root of x on the inside. Done with that one. How about the y? Well, the y is even, right? Or the power is even. Half of 6 is 3, so we're left with y to the 3rd times the square root of x. So once again, if you have anything to the first power on the inside, it's fully simplified, fully simplified. It's like, when a fraction is fully simplified, you don't mess with it again. All right, how about you do this one? Or I got 2 of them. Do these real quick. Pause it, write down the answers, and then check them. Okay, so what you get for the first one? Let's see. Allie, what you got? First one, or top one. That's right. Let's see. 6 is even, so half of 6 is 3, so I'm left with x to the 3. Y is, the power is odd. 3 minus 1 is 2, and the square root of y squared is y. And then remember, we still have to tack on that square root of y because it was odd. All right. Last one. Who haven't I called today? I think I've called on everyone. There's someone is sitting there. Oh, Jack and Ben. All right. All right. Jack, what do you got? Okay, that's right. Let's see. 13 is odd. 13 minus 1 is 12. Half of 12 is 6. So x to the 6th, and then we're left with the square root of x on the inside. Y to the 6th is even, so y to the 3rd. There you go. Good job. Could it be any more challenging? Oh, yes. Oh, yes. We're not done. We actually got two things left. But this one, all we're going to do is combine stuff that we've done before. All right, so all I'm going to do, and I won't make it too complicated for you right now, is simply tack on an integer on the inside, and the integer will be positive. All right, so we're going to use what we did in last night's lesson, or the previous lesson, with this. All right, so if it was just the square root of y to the 5th, I know what to do. If it was just the square root of 12, I would know what to do. We're just going to combine those two options together, or those two things together. All right, so how do you handle this? Well, there's a couple different ways. Some people like to knock out the 12 first. Some people like to knock out the variables first. Some people do them both at the same time. I'll give you my explanation with the variables first. And this isn't necessarily the best way. It's just a way. Well, I shouldn't say that. It's not a bad way. It's just a way, right? I would, unless you're really on the ball, I wouldn't try to do everything at once. So I'm always, maybe it's just me, I always look at the variables first. Okay, so let's see, y to the 5th. Let's see, y to the 5th is odd, 5 minus 1 is 4, half of 4 is 2. So I'd be left with that, yes? And then 12, remember, we're pick the largest perfect square that goes into 12. Well, that would be 4 times 3. Therefore, what's the square root of 4? Square root of 4 is 2. So there you go. So what I did is I just combined today's lesson with what are we on Friday? With Wednesdays and Mondays lesson. Okay. All right. How about 32 b to the 4th? Let's see. Well, b to the 4th is easy. That's even. So we're left with b squared. Nothing on the inside. But the 32. Right. What's the biggest perfect square that goes into 32? All right. That would be 16. And the square root of 16 is 4. All right, you might want to play that again or just pause it and make sure you understand what I did there, okay? Now, granted, there's some of these steps you're doing in your head, some of these you're writing down, and how many you have to write down really depends upon the individual. How much do you need? How much can you handle in your head? How much do you need to write down to look at, okay? For me, I always do the variables and the numbers, not necessarily at the same time, because notice I didn't write the answer right from the start. That's kind of a bit more challenging. I do have an intermediary step right there. All right, you want to do two more? All right, here we go. Well, that one's easy. Let's see. This one probably most people would want to immediately take the square root of 25 because that's a perfect square, right? Now, you can do that. That's fine. But I'm going to stick with my pattern of, variables first. All right, so let's see. I got two variables this time. Remember the square root of x is, well, that's fully simplified, so x is going to stay on the inside. But y to the 5th I can do something with, right? It's odd, so I subtract 1. 5 minus 1 is 4. Half of 4 is 2, so I'm left with y squared. Remember, I still got that, generally people will forget that when the power was odd to leave that one extra variable on the inside. Notice I did leave yx. And you're like, why didn't you write xy? Either one. Remember, in general, in standard form, we go from highest power to lowest power. When they're both the same power, it's generally, we put them alphabetically. But I would never mark you wrong if you didn't. Unless the question said put it in standard form. All right, so what do we have left to do? Take the square root of 25. Square root of 25 is 5. Make sure you understood how I got those numbers. All right, last one, 80. Let's see, we'll get a squared and b squared. That's pretty easy, right? Square root of a squared is a. Square root of b squared is b. Why? Because they're even. Half of 2 is 1, okay? How about 80? 80 is a little bit more challenging. You might not, have to think about it. Some of you immediately see that 4 goes into it. If you put 4, that'd be 4 times 20. Yeah, but there's another 4 in 20, so it's really 16 times 5. See what I did there? Okay. Square root of 16 is 4. Okay. But it wouldn't be wrong if you took a 4 out first. 4 times 20, right? Square root of 4 is 2. And then you'd have to write 20 as what? 4 times 5, and the square root of 4 is 2. So you get a 2 times 2, which is 4. But if you can do it in one step, it's a bit more efficient. All right, here's 2 I want you to do all by yourself. 2 all by yourself. Go ahead and pause the video, knock that out, and then play the video and see what we got. Okay, we good? All right, Madison, first one, what do you got? All right, let's see. Well, you got to remember that 28 can be written as 4 times 7. Sometimes people can't see that there's a perfect square there. Remember, that'd be 4 times 7. The y to the 6 is the easy part. Remember, it's even, so take half of that. And then 28 can be written as 4 times 7. The square root of 4 is 2. So 2y cubed root 7. Cool? All right, last one. Who wants it? Oh, Ben, we haven't. Who did I call on, Ben or Jack? All right, whoever I didn't call on, give me the answer. All right, so let's see. A to the third power is odd, so 3 minus 1 is 2. Square root of, or half of 2 is 1, so we're left with an A on the outside, a B on the outside, an A on the inside, and 45 can be written as 9 times 5. That said a lot there, right? Because remember, 3 minus 1 is 2, half of 2 is 1, so I'm left with an A to the first on the outside, B squared, the square root of B squared is B, and then 45 is 9 times 5, and the square root of 9 is 3. Seems like we've done a whole class yet. We actually have one thing left. All right. I'm not sure. I mean, for me, I would have rather them combine this in another lesson. But they're going to have you solve a simple quadratic equation. Okay. And you're like, wait, I've solved quadratic. Remember, we solved them by factoring before. Here's another technique, and this only works occasionally. All right, recall that obviously 3 squared is 9, right? And that when you take the square root of 3 squared, those two are inverse operations. They cancel each other out, right? But also remember, there's another number that's squared that's 9, and that's negative 3 in parentheses, right? Parentheses negative 3 times parentheses negative 3 is 9. So notice that there's another number that I can write that is also, right? That is also equal to 9. However, when you do the inverse operations of the square root of the quantity negative 3 squared, you don't get 3, you get negative 3. Okay? So there's two answers there, and we've talked about this before. If I give you the square root of 9, which we've all set up to this point is 3, right? We have not taken into account that there's another number that when you square at the bottom in blue there, that when you square it, you get to 9, right? Quantity negative 3 squared is 9, right? We call the positive answer to what's called the principal, right? The positive square root, and we call the other one the negative square root, right? And we generally don't talk much about the negative square root, even though the square root of 9 potentially is negative 3, right? That's called the negative square root. Okay, but why do we generally only talk about the principal square root? Well, when you're dealing with distances, like on a triangle, and you take the square root of something, you can't get negative 3. That wouldn't make any sense. That's why we typically only consider the principal square root. Okay? In fact, most of the time we just say the square root of 9 is 3 and leave it at that. We don't even say what is the principal square root of 9. All right, why am I saying this? Also notice what I'm not saying. I'm not saying the square root of negative 9 is negative 3. This is still no solution, right? There is no number when you multiply it by itself that you get negative 9. Because remember, negative 3 times negative 3 is positive 9. All right. But when we get to solving equations, we have a problem, right? So when you solve equations, right, x squared equals 9, right? Well, there ends up being two answers, right? Because 3 squared is 9, and the quantity negative 3 squared is also 9. So when you solve equations, not when you simplify, but when you solve equations, you have to take into account that there's possibly an answer that is negative, right? And when I say solve equations, I'm talking about solving quadratic equations. All right, so since both 3 squared is 9 and negative 3 squared is 9, we get two answers when we solve this. We get a positive 3, sorry, and we get a negative 3. So recall, linear equations, right? Those are equations when x is to the first power. Quadratic equations are equations when x is to the second power. And cubic equations are when x is to the third power. Okay, we've solved linear equations. We've solved some quadratic equations by factoring, right? Today we're going to be solving quadratic equations by doing a little bit of algebra. All right. Hopefully you understand that to get rid of subtraction you add, to get rid of multiplication you divide, to get rid of squaring, as I've said many times even in this class, you take the square root. They're inverse operations of each other. So today I'm going to give you an equation that's going to involve something being squared. So to get rid of that squaring, we take square roots. So really simple ones, right? X is not by itself. It's got that 2 that I need to get rid of. And that 2 means squaring. The inverse of squaring is square root. So I take the square root of both sides. However, I don't know what X is when I'm solving. So if I don't know what X is, I have to consider the possibility that the answer could be positive or negative. Why? Because remember, when you square something, you only get a positive answer. You only get 9 whether you square 3 or you square the quantity negative 3. So in order to solve quadratic equations, when you take the square root of a variable, you will consider both the positive answer and the negative answer. Okay? So what does that mean? When we solve this equation, when we take the square root, we will put that plus and minus symbol right there. We will not do this for anything other than quadratics, at least for this year, right? We're not going to do it for cubics, and we're certainly not going to do it for linears, right? So when you take the square root of a variable, right, we're going to consider that the answer could be positive or negative. So what's the square root of 9? The square root of 9 is 3. So therefore, to solve that equation, x could be positive or negative 3. Does that make sense? Because think about it. Throw 3 in there. 3 squared is 9. Throw a negative 3 in there. Negative 3 times negative 3 is a positive 9. There's 2 answers there. Okay. Here's how we write the answer. Now, the book sometimes will write a plus or minus 3. In more formal terms, when we're talking about what the value x is, we use the braces form. We go from least to greatest. So we write quantity negative 3 comma 3. So that's how you can write the answer either way. So I don't want to bore you with the algebra because I'm going to give you some pretty easy ones tonight for homework, but we're going to solve for x here. So let's see, to get x by itself, it's easiest to get rid of addition and subtraction first. So what do we do here? Add 25 to both sides. How do we get rid of squaring? Square rooting. But remember, when we take the square root of a variable, you have to consider the positive and the negative answer. Therefore, the answer is plus or minus 5. Okay? All right. Can this get a bit more challenging? Not really. All right. Okay, this one looks a bit more complicated. All right, well, let's see. What do we do to both sides? Add 32 to both sides. Okay, so do we get rid of the squaring or the 2 first? Right, get rid of the multiplication division next. So let's see, divide both sides by 2. Half of 32 is 16. Get rid of squaring, take the square root. Remember, when you take the square root of a variable, you have to consider that the answer could be positive or negative. Therefore, x is equal to plus or minus 4. Cool. Well, that was a bit longer of a class than usual. It is a Friday, so you've got what? Friday, Saturday, and Sunday to get this done. So you got plenty of time. Send me an email. I'll be happy to help you over the weekend if you need any assistance. If not, I will see you guys. Oh, let me finish. If not, I will see you guys on Monday.